Alright, so we're going to be starting off today's session. So we're still on exponential and logarithmic functions. And we want to start off with the question that was given for homework. Now, this particular question, so it's e to the 2x plus e to the x is equal to 12. And I mentioned that this question would lead into a hidden quadratic. Now, hidden quadratics are usually equations where we can substitute a variable to represent something, and we know that the highest power on a quadratic is a 2. So we could look at it like this: e to the x squared plus e to the x is equal to 12. So what this means is that we can take e to the x as a variable. Now, seeing that we already have x inside of this question, let's use y. So alright, so this is where we were yesterday with the homework question. And in order to get it to a quadratic, so this e to the 2x is the same thing as e to the x all squared plus e to the x, and that's equal to 12. So we're going to say let e to the x be equal to y. So now the equation that we're working with is y squared plus y is equal to 12. Now we can transpose the 12 to get this in the general form of a quadratic. So this is y squared plus y minus 12 is equal to 0. Now from this point, we should be able to use AC method to solve this. So this is looking like 4 and negative 3. So it is y plus 4 y minus 3 is equal to 0. So y is equal to 4, or y is equal to negative 4, or y is equal to 3. Alright, so these are the two possible solutions.
Sir, so we would put ln3 since we can get the e of a negative number.
We can't get the e of a negative number.
Well, the e raised to the x, it can be negative. Or e to the x is always a positive number.
E to the negative 5. That's a number. So what we'll have to do here, so seeing that we said y is equal to e to the x, so this is a statement we made, y is equal to e to the x, and we got two values of y. So our first value is negative 4. So we will say negative 4 is equal to e to the x. Now this is where the trouble comes in, because in order for us to get rid of this e to the x, we'd need to take ln of both sides. And as Jaysha mentioned, we can't take the ln of a negative number. So therefore, this negative 4 would be a no solution, not valid, because we'd have to take ln of both of these sides, and we can't have the ln of a negative number, so that is not valid. So now with the second solution, where 3 is equal to e to the x, we can definitely take the ln of both of these sides. So ln 3 is equal to ln e to the x. So therefore, x is equal to ln 3, and the decimal equivalent of that. Well, it all depends, if the question asks for the exact solution, we would just leave it as ln3. However, if it wanted a decimal equivalent, ln3 would be 1.1, and that would be your answer. So that is how we would tackle one of these questions. Now this brings us into the starting topic for today's session: hidden quadratics. Now, as the name suggests, hidden quadratics are those types of exponential equations where we would have to formulate a quadratic equation and solve. So the homework question was just an introduction to what we will be getting into today, and we have many more questions to get through. So let's look at an example. Let's say we got the equation 12 e to the 2x minus 13 e to the x plus 3 is equal to 0. How can we make this into a quadratic? We substitute.
Do you substitute the e for something? Like
Yeah.
where it's or something?
Yes, that's what we'll have to do. So let e to the x be equal to y. So what would be our quadratic equation in terms of y?
Y squared minus 12 y plus 3 plus
13y. So from this point, we can apply our, let me see, AC method 36, and for 13, yes, -4 and -9. Alright, so this would be 12y squared minus 9y minus 4y plus 3 is equal to 0. And of course, to make our lives easier, we could have had the 4y here and the 9y here. So now we can factor out 4y. That will leave us with 3y minus 1. Then we can factor out -3, and that's 3y minus 1 is equal to 0. So we will have 4y minus 3, 3y minus 1. So our two solutions will be y is equal to 3 over 4 or y is equal to 1 over 3. So we have two positive solutions, so that's a good sign. Now let's finish up the question. So since we had said y is equal to e to the x, we can simply say 3 over 4 is equal to e to the x. We take ln of both sides, so ln e to the x. So therefore x is equal to ln 3 over 4. We can just leave the answer like that. It all depends on the number of marks for the question. If it's like let me see, this would probably be like 3 marks, so we could give the answer as that. Or if it doesn't hurt to just change it to its decimal form. So now the second solution, ln 1 over 3 is equal to ln e to the x. So that means x is equal to ln 1 over 3. Is that clear?
Yes, sir.
So that's pretty straightforward. Alright. So let's look at another one. So let's say we had, so let me see, this one is another example, and then I'll give you a few to try. So example 2. So let's say we had 6 e to the x is equal to 7 minus 2e to the negative x. How do we go about approaching such a question? Where do you think we would start?
So would you transpose first?
Alright, transpose first. So can't we substitute y equal e to the x in this question? Isn't it possible?
So I was thinking about it, but then I wasn't sure because it's negative x.
So based on the laws of indices, what is this telling us over here? This particular part of the question is telling us that this is just negative 2 over e to the x. Is that clear?
Yes, sir.
So we have 6e to the x is equal to 7 minus 2 over e to the x. So now we can say let y be equal to e to the x. Now this way we're going to be able to get back our quadratic from that. So we will have 6y is equal to 7 minus 2 over y. And getting rid of this y in the denominator position will allow us to have a y squared over here. Can you see that?
Yes, sir.
Because we'll have to multiply all the terms by y. So multiplying everything by y will give us 6y squared is equal to 7y minus 2. Then we can transpose, get our quadratic, and solve. So 6y squared minus 7y plus 2 is equal to 0. So applying AC method, so this is negative 4, negative 3. So this is 6y squared minus 3y minus 4y plus 2 equals 0. Is that a question for me in the chat?
No, sir. I raised my hand. Because I'm asking, can you backtrack to where to y you multiply that by y?
So we multiplied by y to get rid of the fraction.
Oh, okay, sure.
Alright, so down here we apply factorization by grouping. So this is 3y factored out. That remains 2y minus 1 minus 2, 2y minus 1. So 3y minus 2, 2y minus 1 is equal to 0. So therefore, y is equal to 2 over 3, or y is equal to a half. So once again, we have two positive solutions, which is a good sign. So since y is equal to e to the x, 2 over 3 ln e to the x. So x is equal to ln 2 over 3. That's one of our solutions. Next solution, ln a half is equal to ln e to the x, and x is equal to ln a half. So that's how we approach such a question. Alright, ready to try a few? Alright, I'll take your silence to mean yes. Alright, so I'm going to give you 3 questions. So solve the following exponential equations. Now I'm going to give you 2. So e to the 2x minus 4 is equal to e to the x plus 16. Question 2 says e to the 3x plus 9e to the negative 3x is equal to 6. Alright, so for these 2 questions, I'm giving you 10 minutes. Alright, so let's go through question 1. So we need to solve the following exponential equation. And based on what we've been doing so far, we can simply say let y be equal to e to the x. So y squared minus 4 is equal to y plus 16. Now we need to get everything on one side so we can have the general form of a quadratic. So this is y squared minus y minus 20 is equal to 0. Now, applying the AC method, this is going to be y minus 5 and y plus 4. So y is equal to 5 or y is equal to negative 4. However, this is not a valid solution. Can't take the ln of a negative number. So therefore, since y is equal to e to the x, ln 5 is equal to ln e to the x is equal to ln 5. That's the answer you got?
Yes, sir. Yes, sir. Yes, sir.
Alright, let's get through this one. Same approach. So let y be equal to e to the 3x. So in this case, this is just y plus 9 over y is equal to 6. Multiply everything by y. So y squared minus 6y plus 9 is equal to 0. Applying AC method, so this is negative 3, negative 3. So y minus 3 all squared would be equal to 0. So y is equal to 3. So therefore, since y is equal to e to the 3x, ln 3 is equal to ln e to the 3x. So 3x is equal to ln 3, x is equal to ln 3 over 3. Is that what you got?
Yes, sir. Just 1/3 ln 3.
Yes, same difference. Alright, so are we clear with hidden quadratics? There isn't anything else really to this. We just need to be able to identify what we need to substitute out to get our variable. Then we use it back in the end. If we get a negative solution, we know we can't take the ln of that, so we have to omit that solution. And that's just the basic rule of this. So any other questions on this?
Yes, sir. Could you break down how you got the e to the third part times x to be y squared?
E to the third power, right here?
Oh wait, sir, never mind, I see it. Never mind.
Okay. Alright, so our next subtopic is changing the base of logs. Alright, so let's say we had log base a of x, and we needed to change this to base b. So we need to change from base a to base b. Now this is fairly simple. Log a of x will now become, so we write log base b in the numerator, log base b in the denominator, and we can look at it like this. The big number up here, so the one at the top goes at the top, the one at the bottom goes at the bottom, and that's how we change the base of logs. Let's look at another one. So let's say we had log base 2 of 12, and we needed to change to base 3. So this will become what? What's in the numerator, what's in the denominator? So what's the first thing we write?
Log base 2?
We write the new base that we want to change. So we're changing to base 3. So we have to write log base 3 log base 3. And what goes in the numerator beside this one?
The exponent. So
And the 2 would go down here. So that's a simple procedure in which we change the base of logs. So we, whatever is in the number position, that goes at the top. Or you can even draw a line through it like this. This one goes at the top, this one goes at the bottom. Let's look at one last one. Let's say we had log base A of B, and we needed to change this to base B. What do we write? So log base A of B, and we're changing this to base B. What goes in the numerator? What goes in the denominator?
sir, in the numerator there it would be log base B. Log base B in the denominator.
What goes beside it?
B at the base that you want it to change to. So B.
So the number that goes beside it, is the one that's up here, the number that goes beside the one at the top. And then the base, or the small number, goes at the bottom. However, this can be simplified a bit further, because based on the laws, if we're taking the same base of a number, what's the result? We're 1. So this is just 1 over log B of A. So we need to be able to recognize these laws wherever. Alright, so
Sir, repeat.
what was that?
Could you repeat?
So I'm saying we need to be able to recognize the laws anywhere. For example, this law at the top is the law that states whenever we're taking the log and we have same base so same base as the number up here, this result is just 1. So example, log base 2 of 2 is 1. Log base 7 of 7 is 1. So we just need to be able to recognize this wherever we see it, along with the other laws that governs logs.
Okay, sir.
So let's say we got
Sir, can you go back to that? Okay.
So let's say we wanted to convert log base 4 of 2 to base 2. What do we do here? So log base 4 of 2 will be equal to, what will this be equal to?
log base 2 of 2 over log base 2 of 4.
Can this be simplified?
1 over log base 2 of 4.
Can it go any further?
Oh, 1. So is it that the 2 and the 4 simplify? Would be log base 1 of 2. I'm not sure.
Can this 4 be written in base 2? How else can we write this 4?
2 squared.
2 squared. So that means we can say that this is equal to 1 over log base 2 of 2 squared, right?
Sir, wouldn't you have just stated that it was 2 log 2, 2?
Yes, the 2 would automatically come to the front here. So our final answer now would be what?
Sir, wouldn't it have been a half log?
A half.
Okay.
So that's your final answer. After this 2 comes to the front, we'll have a 2 log base 2 of 2, and we know that that's going to be 1. So it's just 2 in the denominator position. Is that clear?
Yes, sir.
So the reason for this is that we are going to be embarking on a journey where we encounter questions that will require us to change bases. So we will change base from numbers to letters, letters to numbers, and therefore and thereon. Alright, so we'll start with an example. Solve the equation log base 2 of x is equal to 4 log base x of 2. Alright, so this looks pretty tricky, but I promise you it's not that bad. So now, if we're looking at such a question and it says solve, we must first identify where our variable or variables are. Now in this case, the variable we're looking for is x, and we see that we have an x here as a number, like it's in the number position for how we set out logs. We also have an x here in the base position. So now, in order for us to get rid of this x from out of the base position, we'd have to go ahead and convert this part of the question to base 2. That's where we're going to get this base out of the this part here.
So repeat.
So we would need to convert this section over here to base 2 because we want to get the x out of the base. When it's in the base, it's harder to solve for it. So we have to try and get rid of the x from out of here. And the only way we can do that is by changing it from base x to base 2. And the reason why we selected base 2 is because we have a base 2 over here. So that tells us base 2 is the best option to change the base to. Is that clear?
Yes, sir.
Alright, so let's do that. So we're going to be ignoring the 4 for now. So we have log base x of 2, and we need to change this to base 2. So we're going to get log base 2 in the numerator, log base 2 in the denominator. Up top here is the 2, in the denominator is the x. Can we all see that?
Yes.
So now the numerator now becomes 1. So this is equal to 1 over log base 2 of x. And that's just this part. That's the part we took and converted it to base 2. So now if we were to rewrite our equation here, we will have log base 2 of x is equal to 4, and then that 1 over log base 2 of x. Now this 4 here is simply multiplying right here. So we can say log base 2 of x is equal to 4 over log base 2 of x. Is everything good so far?
Yes, sir.
Alright, so my question to you now is, how do we get rid of, or how do we get rid of these logs? So we have a log here, we have another log here. What can we do? Could we have said let y equal log base 2 of x? Is that possible? Or could we have just multiplied both sides by log base 2 of x? Which approach do you think would be
Do you
better?
want to get rid of it?
Repeat?
You want to get rid of both of them?
Well, we want to get rid of the one in the fraction down here.
So you would multiply.
Alright, so let's multiply both sides by log base 2 of x. So now we will have log base 2 of x all squared is equal to 4. Alright, so that's equal to 4. So to get rid of this squared, we simply take the square root. Whatever we do to one side, we must do to the next. So log base 2 of x is equal to plus or minus 2. So now to find our solutions, we can say, so this is in its log form, and to get the solution we'd have to go to its exponential form. So we'd have to say 2 to the power of whatever is over here is equal to x. So one solution will be 2 to the power of positive 2 is equal to x. X is equal to 4. That's one solution. The next solution, 2 to the power of negative 2 is equal to x. X is equal to 1 over 4. So these would be the two solutions for this question. And we can use these numbers to test if our answers are correct. Alright, so we say x is equal to 4. So let's try it back in the original thing up here. So this is log base 2 of 4. And let's see what it gives us. It gives us 2. Now let's see if on the right hand side we get back 2. So we have 4 log base 4 of 2. See, we get back the same answer. Now let's try it with a quarter. So here is a quarter. So we get negative 2. And let's try a quarter on the left hand side. So it's log base 2 of a quarter, negative 2. And that's how you verify your answer. So both of these answers are valid. Is that clear?
Yes.
No confusion whatsoever? So you ready to try one now?
Yes, sir.
Alright. Solve log base 2 of x plus log base x of 2, and that's equal to 2. Alright. So walk me through what you did here.
Sir, I'm not exactly sure if I'm right, so I don't want to risk that.
Can try.
No, thank you. I'm okay.
Alright, so let's see. So we have x being the variable, right? And we want to solve
Yeah.
for that x. However, we have an x in the base here. So what we will need to do is to convert this to base 2. So log base x of 2 to base 2 so something like that, and that's 1 over log base 2 of x. So now what will happen is that we can rewrite this as log base 2 of x plus 1 over log base 2 of x is equal to 2. Now in this case, would it make sense for us to multiply both sides by log base 2 of x? Would that be the best route for us to take? Or we could now convert the log base 2 of x to y.
I actually multiplied both sides by log base 2 of x, and while I was working out the answer, I did realize that I could have substituted, but I still continued working in log base 2x.
Alright. But the best way for us to do this now would to say let y be equal to log base 2 of x. So we will have y plus 1 over y is equal to 2. To get rid of this y, we multiply everything by y. So y squared plus y squared minus 2y plus 1 is equal to 0. Alright, so that's what we have, and we need to solve that quadratic. So this is looking like y minus 1 all squared. All squared is equal to 0. So y is equal to 1. Alright, so y is equal to 1. So we can simply say that log base 2 of x is equal to 1. 2 to the first power is equal to x. X is equal to 2. Is that what you got?
Yes, sir.
Yes, sir.
Because if we were to replace this with a 2 here and this with a 2 here, this is just 1 and this is just 1. 1 plus 1, 2. So that's how we can verify our answer. Alright, so that's the approach we take whenever we are working with these types of questions. We just look where our variable is and look at how best we can convert from the other base in the question. So I'm going to do 2 more and then we'll jump into, of course I'll give you a few to try for homework, then we will jump into simultaneous equations with logs and exponents, and that will be the last topic under logs and exponential functions. Alright, so this is example, I'm not sure which example I am at, but I'll just say example 3. Alright, so let's say we have log base 5 of x being equal to 9 log base x of 5, and we wanted to solve for x. So we know that over here we'd have to change this to base 5. So what we'll have now is log base 5 of x is equal to 9 over log base 5 of x. So I'm skipping a few steps because you should be able to pinpoint what steps I skipped and what should be within those gaps. So now we know that we're multiplying both sides by log base 5 of x. So log base 5 of x is equal to plus or minus 3. So one of our solution will be 5 cubed x is equal to 125, or 5 to the negative 3 x is equal to 1 over 125. So you should be able to pinpoint and add in the extra steps that we took to get to this point. Okay? Any questions on that? Alright, I'll take your silence to mean you understand. Alright, let's look at another one. So 2 more examples. Two more examples. So example 4 and 5. So this example, we have log base 9 of x being equal to log base 3 of 3x. Alright, so this one is a little bit different, but we can tackle it just the same. Alright, so what we will do is we can break apart this 3x using one of those laws. So on the left hand side here, we will have log base 9 of x being equal to log base 3 of 3 plus log base 3 of x. So we broke apart the 3x into its addition counterpart using the law. So we have log base 3 here, log base 3 here. So it would be best to change from log base 9 to a log base 3 as well. So this, changing this to a log base 3 is going to be log base 3 of x over log base 3 of 9, which is 2. And that's equal to 1 plus log base 3 of x. Is everything clear up to this point?
Sir, go over one more time.
Which part of it?
Sir, the question.
The log base 3x over 2.
Hold on, Richards. So this is what we converted to log base 3. So remember, when converting to a new base, we write that in the numerator, we write that in the denominator. What's at the top here goes beside the numerator. What's at the bottom goes beside the denominator. However, 9 is the same thing as 3 squared. So this 2 will come to the front, and that will just be 1. So that's how we have a 2 remaining in the denominator. Can you see that?
Yes, sir.
Alright, go ahead, Richards.
I'm okay now.
Okay. Alright, so from here we can let's see, we can distribute the 2. Yes, we should be able to distribute the 2 here. So this will give us log base 3 of x is equal to 2 plus 2 log base 3 of x. And we're going to bring this over here. So log base 3 of x minus 2 log base 3 of x is equal to 2. And of course, this alright, how do I show you this now? So we have the same base 3. However, there is something we can do with this 2. We can bring it back to the power. And the reason why we're going to do that is because we want to change this to its exponential form. So we want to change this to its exponential form, and that would make our lives much easier. Alright, so what that means is log base 3 of x minus log base 3 of x squared is equal to 2. And then we can combine this as log base 3 of x over x squared. So we're just using the laws here. So now we can say 3 squared is equal to this. So 3 squared is equal to 1 over x. 9 is equal to 1 over x. X is equal to 1 over 9. But what if we had subtracted here? Do you think we would have gotten the answer same way? Right at this point, if we had subtracted, and then we would have had negative log base 3 of x is equal to 2. So this negative is negative 1. So we can see that, right? Because this is 1 log
Yes, sir.
1 log 3 of x minus 2 log 3 of x. So if we had subtracted, we would have ended up with something like this. Then the law told us to bring this to the power. So log base 3 of x to the negative 1 is equal to 2. So yes, we would end up back with the same answer, where we would say 3 squared is equal to this. So 9 is equal to x to the negative 1. 9 is equal to 1 over x. So same thing. X is equal to 1 over 9. So whichever way we do it, you'd end up back, and it's roughly the same amount of working to get to that solution. So I don't think anyone is shorter than anyone. So that's just an alternative we could take to get to the same solution. All right?
Yes, sir.
All right, so I said I was going to do one more example. So let me get one of the challenging ones. If I can find any. All right, these are just basic. All right, let's try one. So example 5. Solve for x the equation log base 5 x plus 1 is equal to 4 log base x plus 1 5. All right, I know Cyan is saying Mr. Doyle is wicked for this one, but regardless, we will get through it. So we look at where the variable is, and that's in the base. So we know that in order for us to get this variable out of the base, we'd have to change to whatever the base is on the left hand side, or whichever side it is on. So we need to convert to base 5. So we're going to be converting log.
Excuse me, sir.
Yes.
Sir, I have to leave right now.
All right.
Yes, sir.
So we're converting this to base 5. So this is log base 5 of 5 over log base 5 of x plus 1. So this is simply 1 over log base 5 x plus 1. All right, so we got that out of the way, so we can rewrite our equation. So on the left hand side we have log base 5 of x plus 1 is equal to, so remember the 4 was on the outside here, so it will be multiplying the 1 in the numerator position. So it is 4 over log base 5 x plus 1. And then from here on out, we can do the same thing. Multiply both sides by log base 5x plus 1. So that will give us log base 5 x plus 1 and this is being squared is equal to 4. So we take the square root on both sides. So log base 5 x plus 1 is equal to plus or minus 2. So we approach this with both of the solutions and we get our answer and we'll be on our way. So let's use the positive solution first. So 5 squared is equal to x plus 1. 24 is equal to x. So that's the first solution. Or 5 to the negative 2 is equal to x plus 1. So this is 1 over 25 minus 1 is equal to x. So x is equal to negative 24 over 25. And these would be your two solutions. Any questions on that? Alright, so I guess everyone is good. So let me put some homework questions and then we'll look at the last topic, which would be simultaneous equations with logs and exponents. Solve the following. That we'll be looking at is logs and exponents in simultaneous equations. So logs and exponents in simultaneous equations. Alright, so we will start with, let's look for a pretty simple one. Alright, so example. Let's say we were given log base 2 of x minus 10y, that's equal to 2, and log base 3 of x minus log base 3 of y plus 1 is equal to 2. So let's say we were given something like this, and as you can see we have two variables in the question now. We have an x here, we have y, we have x, we have y. So we need to solve these simultaneously. So from equation 1, let's see what approach we can take to that. Alright, so equation 1. Alright, so equation 1 can be rewritten as log base 2 x minus 10y Hold on, give me a second. So we can rewrite this as 2 squared is equal to x minus 10y so 4 is equal to x minus 10y. So this could be one equation. We could transpose and say x is equal to 4 plus 10y. So that could be one equation. Let's see how we can restructure the second equation. So for the second equation, we already know what x is. So what we can do, so we're subtracting same base here. So this will be log base 3 of x over y plus 1 is equal to 2. So 3 squared is equal to x over y plus 1. So remember, we already know what x is, So 9 is equal to 4 plus 10y over y plus 1. So we can multiply both sides by y plus 1. So 9y plus 9 is equal to 4 plus 10y. Can transpose 5 is equal to y. So when y is equal to 5, x is equal to 4 plus 10 times 5 equals 54. Is that clear? Any questions on that?
Yes, sir.
You have a question?
No, sir, as in it is clear.
Okay. And then of course we can verify our solution. We can say 54, because x is 54, minus, so this would be 50, because y is 5. So this is just log base 2 of 4, and then we know that 4 is 2 squared, so yeah, we get back our answer. So that's how we can do it, to verify that the solution we got is correct. Alright, let's look at a few more examples. Then I'll give you one or two to try, and we wrap up the session. Alright, so let's look at another example. Log base 2 of y is equal to log base 2 of x plus 4. Then we have 8 to the y is equal to 4 to the 2x plus 3. Alright, so how do you think we would approach such a question? Which part of this question do we even tackle? So we have equation 1, equation 2. Which one do you think it would be best for us to start with? Alright, so my suggestion is that we try and get the log equation into its exponential form. So starting with equation 1, we're going to have log base 2 of y, then we're going to transpose minus log base 2 of x is equal to 4. So we have the same base being subtracted, so we know what to do with the numbers here. So this is log base 2 of y over x is equal to 4. Then going from log to exponent, 2 to the 4th power is equal to y over x. So we can say, so this is 16x is equal to y. So 16x is equal to y. And let's see, so this is now our third equation. So this is equation 3. And we can go ahead and substitute that equation inside of this. So substitute. Well, let's see if we can do anything to this first. Let's see if we can break this down a bit. So we have 8 to the y is equal to 4 to the 2x. So based on the laws of logs or laws of indices, this 8 here is the same thing as 2 cubed, right? And this 4 is the same thing as 2 squared. So that means 2 to the 3y is equal to 2 to the 4x. And then once we have the same base, the numerators, not numerators, the exponents are equal, sorry. So 3y is equal to 4x. That makes sense?
Yes, sir. We did something similar to this in AdMath, I think.
Okay, wonderful. So now what we can do is, we already know what y is, so we can say we're going to substitute that right there. So 3 times 16x is equal to 4x, 48x is equal to 4x, and something is missing. What did I leave off? Did I leave off something? Hold on. Oh, there was something else here. Plus
Sorry,
3.
left off the plus 3.
Yeah. So there was a plus 3 right there. I think that plus 3 should have been in the exponent as well, you know. Poor handwriting, my bad. This should have been in the exponent. So it should have been in the exponent here. So it will be plus 6. Alright, so now we get 44. X is equal to 6. X is equal to 3 over 22. So that's what x is equal to. So now that we have the answer for x, we can say 16 times 3 over 22 is equal to y, and y will be equal to, so 2 into that, 8 3 is 24 over 11. So that's what y is equal to. So that's what x is equal to, that's what y is equal to. And of course, you know, you can put those values in the question to verify. Alright, so that's the approach we take whenever we are working questions like these. So it's either we change from the log to the exponential, or we find a way to reduce the exponential equation. Alright, so this one, so I'll be giving you only one question to try, and then 2 more to add to your homework. So solve for x and y. Log base, well, we don't have any base, so you know what base that is. Log y is equal to log 16 and log x plus log y is equal to log 6. So I'll be walking you through this question, the approach we need to take. So we have two equations. Equation 1 and equation 2. And we need to solve these simultaneously. However, we aren't working in any base. Well, this is base 10, but that right now is not relevant, as what we're going to be doing is we're going to be basically treating this like one of those regular simultaneous equations. What I mean by that is, from equation 2, we realize that we have a log y by itself here, and if we find a way to get rid of that log y, or make that log y the subject, we should be able to substitute the log y right here. So let's rearrange equation 2 to make log y the subject. So rearranging equation 2, log y will now be equal to log 6 minus log x. Alright, so that is what log y is equal to. So this will now be our equation 3. Then we can substitute log y in equation 1. Let's say substitute equation 3 in equation 1. So that will give us log x plus 1 plus 2 times log 6 minus log x is equal to log 16. Alright, so that's what we have so far. Now, this 2 can be distributed to each of these. So we will have log x plus 1 plus log 6 squared. We should all be able to recognize how we get the 6 squared here. So it is 2 log 6, same thing as log 6 squared, minus log x squared is equal to log 16. Are we all on the same page? Richards?
Yes, sir.
Alright, so we're at this point. So we know that everything here is base 10. So we can go ahead and combine everything over on this side. So this is adding. So we know that that's going to be multiplied. So this will be the same thing as log x plus 1 times 36, because that's what 6 squared is. And that's being divided by x squared due to the subtraction that we have right there. So this is log, and that's equal to log 16. So something we should know is whenever we're taking the log of two things, so the same base, same everything on both sides of the equal sign. So this is log base 10, log base 10. So since both of these are equal to each other, that means whatever number we have here would be equal to each other as well. So 36x plus 36, so we just distributed the 36 here, over x squared is equal to 16. So from here we should be able to solve. Alright, so this is 16x squared, so 36x plus 36 is equal to 16x squared. 16x squared minus 36x minus 36 equals 0. We can divide through by 4. So 4x squared minus 9x minus 9 is equal to 0. Now let's see, AC method should be able to work here. 4 times 9, that's negative 36. So this is negative 12 positive 3. So 4x squared minus 12x plus 3x minus 9. So we factor out 4x, we're left with x minus 3. Factor out 3, we're left with x minus 3. So 4x plus 3 is one of our solution, well, one of our factors. So x is equal to negative 3 over 4, or x is equal to 3. So those would be our two solutions for x. So we would need to find the possible y values as well. Now, since we had said log y is equal to log 6 minus log x, so log y is equal to log 6 minus log x. So when x is equal to 3, we will have log y being equal to log 6 minus log 3. So log y is equal to log 6 over 3, and log y is equal to log 2. So if log base 10 of y is equal to log base 10 of 2, that means y is equal to 2. So that's one of the solutions. Y is equal to 2. Now let's see if the other solution will hold. So first things first, we can't take the log of a negative, so this wouldn't be a valid solution, because if we were to put negative 3 over 4 here, negative 3 over 4. That would give us math error or undefined solution. So this one right here is not a valid solution. So hence we only have one solution working with. So we can wrap up and say, therefore, x is equal to 3, y is equal to 2. Are for your homework in addition to what you've already gotten, and this is where we will wrap up logs and exponents.